What's up, kiddos? Here we go. Section 3, Chapter 8. You see the essential question, how do you prove two triangles similar? Remember, that is the shape. Always funny. I feel like it looks like a noodle, a macaroni noodle. Regardless, remember that means same shape. That is what we're talking about. Similar figures, more specifically in this video, similar triangles. Now, let's do a little recap. You're going to see the word congruent triangles pop up here, and there were 5 ways that we were able to prove triangles congruent. There were 5 shortcuts that we talked about. I want you to pause the video, and I want you to jot those 5 down real quick and see if you remember. Pause it right now. Did you get me? That was just my fake freeze frame. Alright, here we go. Let's see if you got them. Number 1, my friends. Angle, side, angle. In no particular order. Number 2, side, angle, side. A third one was the one that we stuttered. Side, side, side. Congruency. And then we had the kind of the goofier one, the angle, angle, side. Remember, there's one that we don't write. No. Those are 4 of them. There's one more. And this was the one that was the oddball. It dealt with all the right triangles. It was the HL posture. Did you get it? Good job, good for you. Now, remember the symbol, the congruent symbol. We talked about this. Just again, a recap. This congruent symbol you break up into 2 pieces. You got one up here that says same size. That's the equal sign. And this little squiggly thing means same shape. Remember, in this particular section, we are talking about similar polygons. More specifically, this section actually is similar triangles, but it means things that have the same shape. Now, we talked about this definition as, again, a recap. The ratios of the measures of the corresponding sides must be equal when we're talking about similar polygons. Not only that, the corresponding angles must be congruent. So this together right here, guys, is your exact definition of what similar polygons are. Now, if we extend that to similar triangles, what that means is to prove triangles similar, we're going to need to do both of these things. Prove the ratios of the measures of the corresponding sides are equal, and prove the corresponding angles are equal. That seems like a lot of work. Just like we had before with congruent triangles, we didn't have to do all that work. We had 5 shortcuts. In this section, you're going to learn actually 4. Specifically, you're going to learn 2. That's really the main ones. But quite honestly, there's really one of them. That's right, one of them. That is the main one that you're going to use 98% of the time in every 2-column proof that we do and all the questions that we actually do. Not in general, but what we do in class. So let's keep going. What you're going to see is a picture. This is an exact picture of 2 triangles that are similar according to the definition that we just talked about. What you got is angle B matches up with angle E. Angle A matches up with angle D. Angle C matches up with angle F. Everything is good in terms of the corresponding angles being congruent. Well, if you look at the corresponding sides and take 10 over 20. The ratio of 10 to 20 is 1 to 2. Well, if you look at the ratio of 6 to 12, that is also 1 to 2. If you look at the ratio of 7 to 14, that is also in the ratio of 1 to 2. So that's awesome. So the ratios of their corresponding sides are equal, and their corresponding angles are also equal. So by definition, you betcha, these triangles are certainly similar. Now, as I just said, I hope there's a shortcut, and there are. So let me show you this next picture. If you notice what I did, I'll just go back. I took these side lengths all the way. Let's say I don't know the side lengths. Let's say that they're really big or really small. It doesn't matter. The question is, are these triangles similar? Well, my friends, what I'm showing you is your very first shortcut to prove triangles similar. It is the A. That's right, the angle, angle, angle postulate. We finally see that. I told you it is not a shortcut to prove triangles congruent, but it is certainly a way to prove triangles similar. So what I'm going to have you do in your notes is this. It's shortcut time. You got it. So in your notes, oh, look at that little thing popping up there. Remember that? That means you better be writing this stuff. So I'm going to tell you the 4 shortcuts. They all start the same way, guys. They all say if there exists a correspondence between the vertices of 2 triangles such that, and we're going to put the 4 shortcuts in the middle, and then at the bottom it's going to say then the triangles are similar. My suggestion to you when you're taking these notes, I would probably skip, after you write this stuff on top, I would skip probably 10 to 12 lines on your notebook, and then write this right there. And we're going to fill in the other 4, as I just said, shortcuts. So, here is shortcut number 1. It is the angle, angle, angle postulate. And it says anytime you have 2 triangles, where you can prove the 3 triangles of one triangle, the 3 angles of one triangle congruent to the corresponding angles of the other triangle, then those triangles are similar. So as I just showed you in that last picture, slide back the video if you need to, but that was an example of 2 triangles that are similar with the angle, angle, angle postulate. Let's keep moving. What you see now, oh, I've taken away one of the angles. So you see here, now I only have 2 angles congruent to 2 angles. So the question now is, are these 2 triangles similar? Well, I would propose to you this, guys. Let me get a different color up here. I have something that you all know called the no choice theorem that would say, hey, if I have one angle congruent to another angle, and I have let me use a different color, another pair of angles congruent, the no choice theorem, remember, says, well then, by golly, that means that this angle right there must also be congruent to that angle there. So why am I showing you this? Because if there is ever a situation where you have 2 angles congruent to 2 angles of a triangle, if I use a little smiley face, 2 angles, whoa, those 2 congruent, and I use a heart, oh, these 2 angles congruent. Wow. If those 2 angles of a triangle are congruent, the no choice theorem allows you to get the 3rd angle, which then indirectly tells you, by golly, you could prove the triangles congruent through the angle, angle, angle postulate. So what I've just actually shown you guys is your second shortcut, which is actually this. It is called the angle, angle similarity. So actually, guys, you do not need to show 3 angles congruent to 3 angles. You only actually need to show 2 congruent to 2 to prove the triangle is similar. And by the way, I affectionately call this theorem not the angle-angle similarity. I call it the squiggy theorem. That's right, you heard me. It's called the squiggy theorem. So anytime you hear me say that in class, that's what I'm talking about. Or I'm just singing. Regardless, that is what the theorem is called. Squiggy theorem. So, anyways, there you go. Write that down. And that one, oh, by the way, I'm going to tell you, I would make sure you take and you star this one right here. Start. That's a lot of stars on that. But start, because this one is the most important one that you're going to use 98% of the time in every 2-column proof. So make sure that one is starred tremendously. Now, let's move on. Because what you're going to see in this next picture, oh, there's the old picture with the, so 2 angles, congruent to 2 angles, wonderful. What if I do this? Oh, what happened there? I took those 2 angles away. Is this even a shorter shortcut? Could we say it's a just kidding. That's a shortcut, if you get it. Anyways, by the way, no, this is not a shortcut. Nice try. Good thinking, but it doesn't work. You can't just take one angle and say, hey, the triangles are similar. You need to show 2 angles, where you can go as far as 3. There are 2 other shortcuts, by the way, that do work. So write these down. It is Theorem 63 and Theorem 64. This is called the squiggy theorem, the SSS squiggy theorem. It says, hey, if you can show the ratios of the measures of the corresponding sides equal. So if you take all 3 ratios and say that they're equal, well, awesome. Then you're able to prove that the triangles are similar. So the picture that we had before, where these ratios, 10 over 20, 6 over 12, 7 over 14, those ratios were all 1 to 2. If we didn't have the tick marks for the angles on here, for all these angles, C and F and all those, but you just had the side lengths, guys, you could show that they're similar through that particular theorem, the SSS squiggy theorem. It would work because you could show the ratios of the corresponding sides are equal. There is one more. It looks like this. So it is Theorem 64. I told you it's the SAS squiggy theorem, the SAS squiggy, S-A-S squiggy. And this one says, hey, if you can take the ratios of the measures of their corresponding sides and show they're equal, just like we did, but then also show an included angle congruent then that makes those triangles similar as well. So the picture looks like this. So if there's a way for us to show that, yep, these ratios are the same, but maybe we only have angle B and angle E given to us, and we show 10 to 20 and 6 to 12. So if there's a way that we can do that, so we show this ratio and this ratio, and then we show this angle. That will be a side angle side similarity situation where you can apply that theorem to prove these triangles similar. There you go. There's your 4 shortcuts. Look at your sample problems, see how they're using 2-column proofs, and we'll see you in class when we practice. Peace out. Later.